So in the problems today, we are going to look at the concept of simple probability. Probability itself is a measure of the likelihood of an event, and simple probability is just the measure of a single event and not multiple events at the same time. So mathematically speaking, simple probability and probability in general is just a ratio, and that's why we had you do some warm-up problems practicing with ratios. So really what we define probability as is the number of favorable outcomes over the number of total outcomes. And what that really means is, when we're talking about favorable outcomes, is the number of outcomes that is the event that we are measuring. So for example, if we were talking about rolling a 6-sided dice and we wanted to know what the probability of rolling the number 2 was, we would set up this same ratio, and since it's a 6-sided dice, there are 6 total outcomes that we could have. And then the number of favorable outcomes, or what we're looking at, is how many ways are there to roll the number 2? And there's really only one way to roll the number 2. So the probability when rolling a 6-sided dice of getting a number 2 is 1/6. So let's look at our first problem. The first problem reads, a drawer contains 5 socks, 2 green and 3 blue. What is the probability a sock pulled out of the drawer at random will be green? Express your answer as a common fraction. So all we need to do is set up that ratio again. And on the bottom, we're putting our total possible outcomes. And in here, we have 5 socks, 2 green and 3 blue. So there are 5 possible socks that we can pull out of there. Of those, we're looking at the probability of pulling green, and we know that we have 2 green socks, so our favorable outcomes is 2. So the answer to this problem is 2/5. All right, so let's look at our second problem. Our second problem reads, 9 cards are numbered 1 through 9. What is the probability of selecting a card with a number greater than 4 or an even number? Express your answer as a common fraction. So for this one, we have a couple things to look at, so it makes it a little more complicated. So first, let's set up a ratio, and we know we have 9 cards, so our total number of possible outcomes on the bottom is going to be 9. So then we have to look at what our favorable outcomes are. So we have 2 things we're considering here, a number greater than 4 or an even number. So let's look at what our options are. So we can draw the numbers 1, 2, 3, 4, 5, 6, 7, 8, or 9. So if we look at our first thing that we're talking about here, a number greater than 4, that means we can have 5, 6, 7, 8, or 9. So that gives us 1, 2, 3, 4, 5 possible favorable outcomes. But we also have to consider an even number. So in addition to these 5, an even number would also be considered a favorable outcome. So there are 2 other numbers we need to consider here, and that's 2 and 4. So out of these 9 cards, 7 of them would satisfy our condition. So the probability is 7/9. All right, so the final probability problem we're going to look at says, what is the probability that a randomly selected positive integer less than or equal to 3,000 is a multiple of 5? Express your answer as a common fraction. So again, there's a few things going on here. So first, we're looking at positive integers only up to 3,000. So an integer is just a whole number, so the positive integers up to 3,000 are just the numbers 1 to 3,000. So if we started here and just said, well, let's set up our ratio, we would know the total number of outcomes that we're looking at are 3,000. And then we have to ask, well, what do we want to put on top? What are our favorable outcomes? Well, we're looking for multiples of 5. So you could start by counting multiples of 5. Okay, 5 is 1, 10 is 2, 15 is 3, 20 is 4, and so on. But it's going to take you a while to count up all of your favorable outcomes for that numerator. So we're going to need to come up with a quicker, more strategic approach here. There's more than one way to do this, but I'm going to look at smaller chunks of 3,000, because if you notice, 3,000 itself is a multiple of 5. So let's look at just the numbers 1 to 5 to start. Just see if we can kind of develop a pattern here. So if we look at 1 to 5 and we set up that same ratio, looking at multiples of 5, total outcomes are going to be 5, and there's only one multiple of 5 in there. That's 5 itself. Okay, so 1/5. All right, so what if we looked at 1 to 10? All right, if we look at 1 to 10, then now we have 10 total outcomes, but we now have 2 multiples of 5. We have 5, and we have 10. So there's 2 multiples of 5. And if we simplify that to a common fraction, we get 1/5 again. All right, let's look at one more. So if we look at 1 to 15, similarly, we're going to have 15 as our total, and then we now have 5, 10, and 15 as our possible favorable outcomes. So 3/15, which again simplifies to 1/5. So we don't need to go ahead and go all the way up to 3,000. We're going to know that as long as we're looking at the numbers from 1 to a multiple of 5, it is always going to be 1/5. So our final answer here is just 1/5.